Okay, so this is problem number 17 in the chapter 5 homework on page 151 about kinetic energy. So this problem calls for you to find the resulting speed of a car that is being pushed 20 meters at 1000 newtons force pushing forward and 950 newton force pushing backward. So the first thing you need to do is put it into the equation. Work equals force times distance cosine of the angle between the movement and the direction of the force. So our unknown here is work, so we're going to place that there. We know the resultant force, which is 1000 minus 950, which is just 50 newtons. The distance we know is 20 meters, so 20 meters, and cosine of 0 is just 1, so we can just put that 1. Work equals 1000 joules. Okay? And then the next thing we need to do is plug it into this equation. So work equals 1/2 mass times velocity final squared minus 1/2 mass times velocity initial squared. So this is basically the equation for the change in energy, given that it has a velocity initial and velocity final. Because this problem, in the problem it indicates that this car has started from rest, we can immediately equate this to 0, because anything that starts from rest or anything multiplied by 0 will always equal 0. And because VO, or velocity initial, is 0, this whole term would be equal to 0. So the real equation would be work equals 1/2 mvf squared. And then we substitute in our work because we know that it's 1000 joules equals 1/2. We know the mass is 2000 kilograms, and we don't know the velocity final. So we can multiply 2 to 1000, which would make 2000 joules equals 2000 kilograms velocity final squared. We divide both sides by 2000 kilograms, which would give us 1 meter squared per second squared equals velocity final squared. We take the square root of both sides. Velocity final equals 1 meter per second.